Let's see how to create a Modbus RTU sniffer, the result of which is what you see on the screen. In this example, we intercepted the communication between a hot mills inverter and the Chint electric meter. As we will see later, we have the Chint manual with the Modbus register list. To do this, we will intercept the RS485 communication cable as shown in the diagram. Using an RS485 to TTL converter and an ESP01 relay, we will also use a modified ESP01 to USB adapter to program it and flash the ESP8266-01. The modification consists of a system to short-circuit the GND and GPIO0 pins. We do it with a 220 ohm resistor and a breadboard. To program the ESP8266, we used the Arduino IDE and did so with the help of Google Gemini. Let's download the program. Look in the description of this video. We downloaded and opened it with a text editor. We selected everything and copied it to the clipboard. Now we open Arduino IDE. We select everything and replace it with the code copied above. We name and we save. Let's install the board in the IDE. First, we need to add the board manager repository. Go to Preferences and paste the URL, which is also provided in this video's description, and click OK. Go to the motherboard manager and search for ESP8266 and install it. We insert the USB with the connection ready to flash. We select the board and the USB port. To choose the board, we must search for generic ESP8266 module. We tried compiling, but the ESPasing TCP and ESP-ASIC web server libraries are missing. Go to the library manager and enter ESP-ASIC. You must select the ones for ESP32ASIC. Install them one after the other. Now we can compile and flash the microprocessor. We disconnect the USB, disconnect GPIO 0, and reconnect the USB to test if we can connect to it even without data. We connect to the sniffer's Wi-Fi. The password is 1234567 and 8. We open a web browser, Chrome in our case. We enter the web address 192.168.4.1 and the sniffer page should appear. Now we need to make the connection on the cable. The connections between the ESP01 relay and the RS485 converter are also shown here. In the description of this video there is a link to the video where we show how we physically made the connection on the RS485 cable. We put the microprocessor in the ESP01 relay, connect to its Wi-Fi, and open in with the browser. As we can see, the real-time communication log is generated. Since we have the counter's log table, it will be very easy to decipher this communication. We pause the reading to analyze the communication. We immediately see that, being a solar inverter with a battery, the most important data for it is the instantaneous power, whether positive, import, or negative, export, so it alternates reading this with one of the other data points. Its value is 0 because at this moment everything generated is used to charge the battery. The hexadecimal register, 2000E, contains the frequency 50 Hz in Europe. The 4000 and 4000 values contain the active and reverse power. The inverter requests the entire range but only uses these values. Another example is the 2000 and 2002 registers, which contain the voltage and amperage. We can also download these values into a comma-separated .csv file which can then be processed in a spreadsheet program like Excel or Google Sheets, not directly as shown here. We will try to make a video using this to export data to Home Assistant. That's all. Thanks for watching until the end.